Hi folks, we're going to take a look at a first example of writing a balanced chemical equation starting with a word equation or a description of the reaction. So here we've got potassium iodide, which reacts with chlorine to give you potassium chloride and iodine. Okay, so the first thing we have to do is we have to translate these chemical names into chemical formulas. So we do this exactly as we would have done before. Okay, we have to make sure that we know what kind of compound this is. So here we see a metal and a non-metal, and we don't see any prefixes, so that means it's an ionic compound. So we need to look at the charges here, and we see that potassium has a charge of +1, and iodine, if we go to the other side, its ion has a charge of -1. Okay, so that makes things pretty easy. We just need one of each to create our neutral compound. Okay, next we have chlorine, Cl. But we have to keep in mind that chlorine was on that list of diatomic molecules. So that means this exists as a diatomic molecule, not just chlorine on its own. Okay, so that means that instead of just being Cl, we're going to have Cl2. Okay, and now let's look at the products. So potassium chloride, so we already know potassium is +1, and now we go to the other side and we see that chlorine's ion is also -1. So again, fairly easy, just KCl for our chemical formula. And iodine is yet another one of those 7 that exists as a diatomic molecule. So here plus I2. Now, just to keep in mind, the ones I expect you to know are oxygen, hydrogen, and nitrogen. If you were to use one of these others, I'd give you some sort of hint or indication that you'd have to consider a diatomic molecule. Okay, so now what we have here is we have our skeleton equation. We have the chemical formulas for products and for reactants and products. Now we just have to balance this equation. Okay, so like we said, it's usually good to start with the metals, and we see here that we've got potassium, and there's 1 on either side of the equation. So that's already balanced. Okay, let's take a look at chlorine here, because it looks like I've got 2 on the left, but I only have 1 on the right. Okay, so here, in order to balance these 2 chlorines with that 1, I'm going to have to add a coefficient of 2 in front of the KCl. Remember, that's the only thing we're allowed to change, is the coefficients in front of the chemical formulas. Okay, but now in putting this 2 in front of the KCl, I've balanced the chlorines, but now the potassiums are no longer balanced. So because I've got 2 chlorines on the right, I now have to add a coefficient of 2 here in order to create 2 potassiums on the left. So now we've got the chlorines that are balanced and the potassiums that are balanced. Now let's take a look at what's happening with the iodines, and we see that I have 2 on the left and I already have 2 on the right. Okay, so in this case here, they're already balanced. Okay, so again, step number 1 is translate these chemical names into formulas. Okay, make sure if you have an element that exists as a diatomic molecule that you include the subscript 2, and then once you have your skeleton equation, you can go ahead and balance as we did before. Okay, that's it for this one.